Okay, let's give this a shot, and if it doesn't work, well, good talking to you. I'm speaking with James Bunnel, and James grew up in Marfa and Presidio, and he lived in San Diego for a while, but I consider him a West Texan born and bred. He worked for, he was an engineer, so thank goodness for the West Texas school system. He worked at BAE Systems as a director of mission solutions for Air Force programs. And he was a member of the launch team for manned Apollo launches, including, James, am I right? Did you work with Apollo 11 in any capacity?
Yes. I was part of the team threw up for all the manned launches under Apollo.
That's almost an interview in and of itself. Apollo 11, for any who aren't old enough to remember or haven't checked on it, Apollo 11 was the first footsteps on the moon by humankind. So if you worked on that, wow. But James, you have investigated the Marfa Lights, and that's near and dear to my heart. I'm a kind of a transplanted West Texan, and I've been hearing about the Marfa Lights since day one. And you investigated these things in a way that I consider just to be the epitome of honest, humble, amateur science. And by amateur, I don't mean that it's not professional in skill. I just mean that you didn't get funded by some larger corporation or institution.
That's right. It was self-funded.
Let's start with the punchline, if I may. So science works with what's going on and why is it going on. So just give us a little bit of both. What's happening and why is it happening when you visit?
What happened was, I'll give you just a little bit of history, a slice of history here. Mm-hmm. I probably saw the lights the first time when I was maybe 4 or 5 years old when my grandfather took me out. And I didn't know what I was looking at. But we were living in Marfa at that time, and he showed them to me, and I think he believed, he was a smart guy, and I think he believed they were car lights on the Presidio Highway. And most of the time he'd be exactly right, because those car lights are there every night. And they do look mysterious because it's a winding mountainous road, and those you see lights that turn on and off. But in addition to car lights and ranch vehicle lights and all of the explainable lights, there is another phenomenon that goes on, and it's I thought if I could, the first camera that I set up was for the purpose of trying to find out a way to predict when they were going to be there, and then I'd be there ahead with my 8-inch telescope, and I'd find out what they were. That didn't work out because I discovered there was no way to predict when they were going to appear.
If these are headlights, and the idea is that they're headlights, I guess, that are refracted by strange mirages of temperature, if these are car lights, why are they dancing around like this? And how do they produce a third light? And how do they coalesce?
Well, there are different reasons why some of those things happen, including a tendency that people have to move people don't hold their heads still. They think they do. But often when I was out there, I'd be near people that would be watching a ranch light, and they would say, oh, look there, it's moving to the right, and it's doing this, it's doing that. If I could get them to line up what they were looking at with a telephone pole or something that was a fixed object, then the motion would all stop immediately. There's that factor. The highway lights they're pretty interesting too, because that winding road, the lights turn on and off because of terrain masking. And the road winds around, so it looks like at times there'll be multiple cars, and it looks like they're merging because they're going around the curve, and it looks like they're turning on and off, which is what the lights that are so interesting do also. So there's a lot of room for confusion or misidentification of explainable lights, and so it's kind of understandable that people go out there and they take a look and they say, oh, these are just car lights. The problem is that based on my experience, at least during the time that I was out there searching for them, the chance of having a night with the real stuff was only about 1 in 30. So given those odds, you can see that most of the time people are really looking at car lights, and that's the reality. But it's unfortunate because it obscures the fact that there are some really fascinating phenomena going on. It's just that they're rare, and we can't predict when they're going to happen. And so that makes understanding what's going on more of a challenge.
Well, I think you've leveled a pretty big accusation, which is that people don't want to hear that what they're seeing comes largely from inside their head. They want to hear that it comes from outside their head. And what you're saying is, and we'll get to, you have basically, for you, there are two different flavors, two different species of Marfa Lights, and we'll talk about that in the next question. But I just want to clarify, you're suggesting a lot of what people say when they're talking about the most dramatic events of Marfa Lights, lights following them inside their car and driving with them, and lights dancing around and almost, spelling out words and things. You're saying that is something that is it too strong to say, are imagining?
Well, it depends, Jason. I'm saying that there are a lot of opportunities for people seeing identifiable, understandable lights and misunderstanding what they're seeing. And they're maybe not spending a lot of time there. They're not skilled observer, and so it's understandable that they expecting to see Marfa lights and they see lights and they assume they're seeing the real stuff. But it's also true that sometimes they really are seeing the real stuff, and the real phenomenon can be very interesting.
You have two books that I looked at. One was Strange Lights in West Texas, and the one that I looked at more closely is called Hunting Marfa Lights, and it is. I loved it. To me, it's actually a book about West Texas in a very intrinsic way, as much as specifically about the Marfa Lights. And well, rather than give you a book review, I'll ask my question. I think you mentioned somewhere in there that you saw at one point two headlights from trucks coming down the road, coming down 90 towards you, and then a few seconds later they disappeared or they were gone. Have you ever thought you saw something that turned out not to be there? Yes. In fact, one of the things that happened, and this was late in my, I did this research for about 12 years, and toward the end, I was picking up some lights that were discontinuous, which would mean that they were plasma. And because I believe that these things are fundamentally, and at least at the heart of them, or their plasma, I was intrigued by that, and I shared what I was seeing, what I was photographing with a colleague who is an engineering professor, and he said, those could be car lights with plasma headlights, and you ought to consider that. And so I said, okay. So I went back and I looked up plasma car lights, which had come into vogue not really pretty recent, toward the end of my investigation. And sure enough, I got an exact match of the spectra, and so I retracted any thought that those were the mystery lights, the MLs, because they were car lights that had plasma. Okay, so you got some plasma lights from trucks tricked you, but you buried the lead there, and I'll repeat it. You have basically determined that there are two flavors of lights when someone sees lights, bouncing lights at the viewing station. There are car lights, which I suppose are refracted by some weird heat because they look kind of weird for car lights. But also, and much more, to me, interesting and exciting, you believe that there are lights that are caused by plasma, and plasma is overexcited particles that don't want to stay in their atomic shell. And plasma was around at the very beginning of the universe. It's around in stars. And it's not a form of matter that we see every day unless we have a plasma light. How on earth do you think the plasma is getting to Mitchell Flats in West Texas and coalescing and letting us see it?
Yes, and the answer is not simple. Let me pick that apart a little bit because you included several things there. Mm-hmm. One of them is you had mentioned people being chased on US 90 by these mystery lights. And I've looked into some of those, and they turned out to be, I'm convinced that they were mirages that appeared to be chasing the car because of the way mirage lights behave. And I cover that in that last book, Strange Lights in West Texas. There's a chapter that talks about that and gives a couple of examples and explains how that works and why it works the way it does. So there's that aspect. With regard to plasma, these lights, these mysterious lights, what caught my attention and really got me to start investigating was that they were exhibiting, these MLs were exhibiting behavior that was hard to explain. If they were not car lights and they were exhibiting characteristics that seemed to eliminate that possibility, then they were doing things that just didn't seem to be explainable, and that really caught my attention. And ultimately, I did decide that at the very heart of them, they're plasma. But it took a while. In the book that you're enjoying, Hunting Marfa Lights, I listed 4 hypotheses, and along with pros and cons for each one of them, because I still was groping to try and find something that really seemed to tie everything together and that made sense. And that was published in 2009. By the time we got to the last book out in 2015, my understanding and my of what's going on had further developed. And I started to realize that the only way this made any sense is that the mystery lights, the MLs, were really a duality, that they were both conventional fires and plasma, with plasma being the energy source for them.
When you say conventional fires, what do you mean by that?
What I mean is that when I was photographing lights that I believed were MLs, convinced of that, and there was good reason to believe that, and I checked spectra, the spectra was continuous. And the fact that it was continuous says that it was not plasma. But the behavior of the lights had characteristics of plasma. They turned on and off, and they most important of all, most shocking of all, they were not wind responsive. When they were stationary, they didn't bob in the wind, and the wind would be gusty out there sometimes, and these things would be steady as a rock. But usually they were in motion, not stationary. And when they were in motion, they'd go where they wanted to. The wind would be blowing one way, they'd be going right into it often.
But isn't that also the behavior of headlights? That sometimes they would seem like they're steady and still, and other times they would seem like they're moving?
Well, yes, you can do that with a headlight, sure. But these were not headlights. They were in the air. They were above ground, and they were following a path and exhibiting behavior, their turn off and turn on behavior, characteristics that convinced me that they were indeed mystery lights. Plasma
is a fourth state of matter. You don't come across it every day. You can't kick it. You can't pour it in a glass. It's this fourth state of electrons without a home, so to speak. And how on earth would they get to Mitchell Flats? And by the way, feel free to kind of take over my explanation and make it more clear or more suitable to the truth.
Yeah, well, I think your explanation was pretty good. Plasma is the most common form of matter in the universe because stars are plasma. And we have on Earth, natural plasma is somewhat rare. Of course, we have plasma TVs and things, but those are, they produce light, but it's done in a very controlled way inside a cube or something where it's contained. But some of the things that we see that are plasma that we see from time to time would include lightning. Lightning is plasma. And one form of lightning is ball lightning. Ball lightning is a peculiar thing. Science recognizes ball lightning. They haven't gotten around to recognizing Earth lights, or MLs as I call them, just yet. But they do recognize that ball lightning exists, that it's real, and they've been studying it for years, and they still do not fully understand it. Kind of weird stuff. But the explanation of all of that, I can give you. We might come back to that another time. For right now, we'll just talk about. We'll get back to your fundamental question: is what would cause plasma to be in Mitchell Flat? And the answer to that has to do with how it's being generated. I eventually concluded that it's essentially a form of ball lightning. Now, it's different than ordinary ball lightning. Ordinary ball lightning seems to be associated with ground-to-earth strikes, and when you have the lightning come down, it comes down in a very zigzag form. And if you have a collection of positive ions riding along in that stream, and there's some reasons for that we'll skip over for right now. The lightning makes a sharp departure somewhere, and the positive ones continue on, and they end up being a little ball of light. It floats out across the ground. And the thing that's unique about the ball lightning is that it has some behaviors that are quite surprising. It can pass through walls and through windows, and even into airplanes in flight. We have records of all of those things. And it has to do with the disassociation of the atomic structure, which you referred to. Everything that we see in the world around us is made up of atoms. And they've got a center that is protons and neutrons. Protons are positive and the neutrons are neutral. And they're the heavy elements. They're the bigger parts. But orbiting them are the negative parts, which are electrons. And there's a whole science of how atoms swap those electrons, and that changes the characteristic of what the element is and makes the difference between one element and another kind of element, or its characteristics. But when you start applying heat, the structure that holds all of this stuff together starts to break down. Let's take water, for example. At a very low temperature, we call it ice, and it's so rigidly coupled that you can walk on it, as you know, or slide on it at least. You add some temperature, and it converts from a solid into a liquid, and then you can dip your hand in it, but you can also float on it. It's got enough consistency that you can fly. You can make boats and sail around on it. Add more heat, and you get into steam, and now it's you put something in it, you're going to fall through. The association is much less rigid. It's almost minimal. But when you add even more heat up in the neighborhood of 4,000 degrees or more, the atom structure itself breaks down, and you still have electrons and protons and neutrons, but the electrons are not orbiting the centers anymore. They're in some kind of organization that I'm not sure today we even know exactly what that looks like. They usually refer to it as a cloud. But when you get to that state, the properties are so different that the lightning or ball lightning can go right through a window or a door, and so it's very unique. And these mystery lights seem to have that capacity as well, based on the way they react to air currents.
Okay, ball lightning is now my current favorite thing in the universe. Can it be created in a lab?
Yes, there are people who have generated that in the lab. The ones that I've talked to or that I've read about it's only lasted microseconds or, really short period of time. And what makes what makes these MLs so interesting is that I think they are a form of ball lightning, but they differ from the type that we get with normal lightning. For example, ball lightning, the median time that I've looked up for ball lightning is 5 seconds, and with a maximum time of 23 seconds. The median time that I've gotten on the MLs is 4 minutes. That's 48 times longer. And
again, I'm sorry to interrupt, but I just want to emphasize something here that you're just kind of glossing over. Okay. What you're saying Mitchell Flats is producing something, and given that you're a scientist, you're not saying it's guaranteed, let's be fair. You're saying this is what evidence suggests. That Mitchell Flats is producing something that cannot be produced in a laboratory and cannot be harnessed and captured. You're basically saying Mitchell Flats is producing something that is basically unique or new to science. Is that right?
Let's say that it hasn't been created. I won't go so far to say that it can't be, because if people really worked at it hard enough, and they might find a way to do that. But it hasn't been, to the best of my knowledge, nobody has produced something that has durations as long as we're getting with these MLs. And so yeah, it's something. It's a part of our physical world that Mother Nature is giving us a peek at with these Marfa Lights, and that's why it's really amazing stuff. And if we understand it better and really learn how to make use of it, we might be able to do some really amazing things, like walk through walls ourselves.
Unbelievable. How do these things, to the best of your hypothesizing, how do these balls of plasma get into humble Mitchell Flats in very innocent and untouched West Texas?
An excellent question. And as I mentioned earlier, they also show up many other places around the world. So Marfa's a really great place to look for them, because it's high desert, and it makes it easier to find them and see them. But they do show up many places. And how do they? What causes them? How do they? Where do they come from? And the real key to that is something that was done by a NASA scientist by the name of Dr. Friedemann T. Brion. Not sure I'm pronouncing his last name right, but he's a NASA Earth scientist, and what he discovered was that igneous rocks under pressure start to behave like batteries. And he's proven this in the lab, and he's shown that you can produce some amazing currents just by squeezing igneous rocks. Well, if you look at Marfa Basin was formed by the collision of some tectonic plates a long time ago, and northern plate is called a diablo shelf. That's being subducted under the Marathon uplift, which is more of an African plate that's coming up from the south. And what you get when you have a situation where one plate is being pushed under the other, subducting, it pushes it down into the mantle, and the mantle is liquid, and it's extremely hot. So it starts melting the plate, and you get volcanoes. That's what's happening in Hawaii right now is a situation like that. You get the shelf that's being, or the part of the plate that's being pushed down into that molten stuff. It starts creating volcanoes that come up through the one on top, and so you have we had a situation like that about 35 million years ago, and that created the Marfa Basin. There's a feeder tube. That's where the molten lava was shooting out of Paisano Peak, which is you pass right by it on the road from Alpine to Marfa and vice versa, and it's a little less than 7 miles from the view park. And it was one of the things that was pumping stuff into the air 35 million years ago. Chinani Mountain, which is further away, was probably doing a bigger job of that, and it layered that whole Marfa Basin with ash that blew out of that volcano, and that's all history. Okay, but.
So James, let me just make sure I'm caught up. So the question is, where does this plasma come from? And you're saying, and you're going to finish off your explanation. I just want to make sure that I'm caught up. That basically under the earth are these humongous forces of nature that take one plate of land and slide it under another plate of land. These things are so immense that they create intense heat, and with heat comes energy and movement, and that's got to go somewhere, and it comes up through what you call the feeder tube, and this happens around West Texas. So if I've got that right, then continue on, but if I've got that wrong, then correct me.
No, that's good.
Okay.
That's good.
So
and
keep going.
Now let's get back to Friedemann Freund and the discovery that he made, that igneous rock, when it's put under pressure, starts to act like a battery. Mm-hmm. And what it amounts to is that when you have a large amount of igneous rock under pressure, as we do in the Marfa Basin, you can get extremely large voltages. At least that seems to be the implication of what his findings are. Now, what I think is happening is that we have fault lines running through Mitchell Flat. There are a number of them, and I have them in my last book, shows where they're located. And so the situation underground, like maybe 3,000 feet down, may be somewhat like the situation that happens in the air when clouds bump into each other, air currents are moving moisture through the air and creating friction and generating static electricity, and it builds up to the point that we have lightning discharges. Now, the underground analogy there is that you've got some massive chunks of rocks with enormous voltages or currents that are separated by some faults, and you have the opportunity for discharges. And those discharges, the reason that these things are so unpredictable is that it's like trying to predict an earthquake. Nobody has really been able to do that too successfully.
Okay, so let me jump in, just so I can catch up. So the igneous rock compressed by these plates creates a battery, we think, and much like lightning comes from the sky and is plasma that is generated by pressure and friction, you're suggesting, and then you can keep going, I just want to make sure I'm caught up, that the compressed igneous rock creates basically lightning coming from 4,000 feet under the ground, this plasma?
Yeah. 3,000 feet or more, but at least
hit it. Keep going.
Based on the data that we've seen from oil drilling, because you have to get that deep to get into hydrocarbons, and these things appear to be hydrocarbons or related to hydrocarbons. At any rate, what I suspect is happening is underground lightning, that these very energetic rocks that are being they carry currents and voltages as a result of the pressures that they're being subjected to, that in that particular unique place below Mitchell Flat, we're getting discharges occasionally, which amount to underground lightning, and they are so intense, they have such high voltage that they completely strip the atomic structure of the hydrocarbons that they're passing through, and you get a special kind of ball lightning. It's not really a ball anymore. But it rises up because the atomic structure is gone. It's able to move up through that terrain and into the atmosphere.
Shouldn't these balls of lightning, this plasma, that are the rarer but more exciting Marfa lights that many people see from the visitor center, shouldn't they create their own heat signature? And I know, let's go over, you have set up cameras because you can't always trust your eyes and you can't be there all the time. You have looked through binoculars because your eyes are not as good as 10 by 32 binoculars. And you've also used spectrometers, which kind of like look at a light and tell you what its picture means through a prism. But by gosh, plasma, in the same way that I can, feel lightning, I suppose, if I'm close enough to a bolt, shouldn't I be able to feel plasma, or shouldn't it melt something on the ground or something very dramatic like that?
Good question. Let me address some of that. What we've got here, and it took me quite a while to figure that out, because when I would take the spectra of these lights, it would be continuous, and that says that it's a conventional fire. That is, that it's gas burning. It looked like from the spectra that it was probably oxygen fire, which is interesting, but that's not plasma. And so where does plasma come in? And the real question, though, that was plaguing me as an engineer when I was earlier in the research is, where is the energy coming from for these things? How is it that they're able to have such long lives? Because if they're just a hydrogen fire, then they should burn out pretty quickly. And even if they're plasma, they should burn out pretty quickly. And yet they would go, 10% of them lasted 40 minutes or longer. And that didn't make any sense to me, because and they would turn on and off. And how were they able to turn on and off? What was the ignition source? What I finally realized, and it took a while, was that their duality, that what I just described for you was the creation of the core of the ML, which is a plasma core that comes up from deep below the ground into the atmosphere, and it's extremely hot. And when it gets in the atmosphere, it starts to, the outer edge of it is cooling off because it's radiating into the atmosphere, which is cold. And so the atoms start forming on that outer edge, and reforming as atoms because they're dropping out of as the temperature decays, it does a transition from plasma back into gas, and it's doing it at a temperature that's still above the auto-ignition temperature of hydrogen. So you get flame erupting around. There's the ball of light that we're seeing is a conventional gas fire, and that's why what we're getting is spectra that corresponds to a gas fire instead of the plasma. But what's feeding that, the fuel that's feeding that fire, is the plasma core. And the fire that's created keeps heating up until it reverses the situation. It dries, it burns up the stuff that is in the form of atoms, and it goes back to plasma. The light goes out. It's dark for a while, but then when that happens, the temperature transfer accelerates, and soon you have a gas fire going again. And these things do that. They turn on and off multiple times, and eventually they exhaust that plasma core and go out completely.
James, let me do my catch-up that I've done for the last two explanations. So I'm going to talk about what you're talking about, but using gas and liquid and solid. You're saying basically that plasma emerges in the form of ball lightning, and that as it cools down, it reintegrates itself into the more conventional atomic structures where you have protons, neutrons in the nucleus, and then electron clouds surrounding it. Could this be compared to, for example, you have a vent in the earth that heats up water into a gaseous state, and the water erupts madly from this vent. But as the water erupts, it is cooled down, and it turns into steam, and then it turns into liquid. And so by the time this steam gets into the air, you already see it cooling down and turning into liquid. But, different days it might take longer, different days it might be shorter, it might be more dramatic. If it's raining out, it might be less dramatic. If it's snowing, that kind of thing. Is that a fair comparison?
Now, let me just say, and I'm going to go a little bit further with this, but first let me say that I know that what I've been describing here involves a lot of stuff, and it's a pretty big step to take. But Chapter 7 in that Strange Lights book that you said you have spelled that out nice and more clearly than I was able to do in my brief discussion here. If you read back through that, I think it'll help. And Chapter 9 goes into a little bit of speculation about the importance of what this might all mean and why these things are important, and we should be studying them. Real scientists, not just amateurs like me, but real scientists need to dig into this stuff and find out more about it, because the opportunities here I think are enormous. And the reason I say that, and this is really fundamental. What I'm saying is that in that conversion process is ongoing, because the lights turn on and off as and this is a characteristic of these things, by the way. Is one of the clues that I've got an ML instead of something else is that I see it turn off for a while, I wait a while, and it reappears right on track where it was. But the plasma itself, interestingly enough, is dark matter in effect, because it's not emitting protons. So when this fire
it's not emitting photons, PHOTONS.
Yeah, it's not emitting light that you can see. Right. And so when the gas, hydrogen gas and oxygen burn and exhaust that, it goes out. But then the temperature gradient between the outside cool air and this hot core causes more transformation into gas, and the fire reignites, and it keeps doing that until it's exhausted that core.
Well, I want to jump in and say critically here. What you're describing is dark antimatter, but it is not necessarily the dark matter that we witness all over the universe. We don't know what dark matter is. And as such, what you're describing is dark antimatter. We don't know. Okay. So I just wanted to.
I'm saying dark plasma, and plasma is weird stuff. It's got different kinds of plasma, and included in that version, one version is one that does not emit photons, and so it's dark, and you can see through it. And we have that. If when you look at the night sky, you can see stars, and yet we're looking right through radiation belts. There are a couple of radiation belts that are very intense, really. And we know this for a fact because we have spaceships up there. We measure those conditions, and we know that there is these radiation belts, and yet we can able to see right through them.
James, I know you have more to say on this, and we can come back to it, but don't want to just talk about the Marfa Lights. I want to interview you about yourself as well. So if you don't mind, I'll come back to some of the other more plasmatic issues. But you are a modest guy. I consider you to be a real scientist. I, in fact, consider you to be more legitimate of a scientist than I consider people who get enormous grants and who work for large institutions. You are looking at this thing through a labor of love, which I have my own reasons for thinking that is a more honest version of science. If you're right, even if you're wrong, and you're intelligently wrong, then you've come across something which is really significant, which is valuable to people everywhere to know about, because it may generate into something more frankly useful than just witnessing the Marfa Lights. If we have plasma that lasts 4 minutes above the surface of the Earth, that can be something that is even turned into technology. So here's my question to you. What are you going to do with this?
I appreciate your thought. And, what I have done is to write some books. That's really all that I've done with it. I have science friends that I talk to about this, and there are other people that are interested in these Earth lights too. The people in Hessdalen it's a funded operation with government involvement and university involvement and a lot of PhDs, and they're very proud of what they're doing. But just between you and me, I think there's still some things that they need to work on there, and this is a very, very interesting subject, and it does need study by people who can really do something with it. What I think the next step here is something that I can't do, I'm not going to try to do, and that is to research this in a laboratory. Find out if any of these ideas are real, and it needs a laboratory to do that, and real scientists can do it. But they need to have the connection to those laboratories to be able to do it.
There was who's the guy who invented the microscope? Leeuwenhoek, I believe. Are you familiar with him? The reason I bring it up is because he never wrote a book. In fact, all he did was correspond with the Royal Society. This is in the 1600s, the late 1600s, I believe. And they collected his letters and eventually published them. But the idea was that he was an amateur scientist who was he had another job. He was looking at microscopes, developing them, shining the glass, and seeing cells for the first time. And he was, in fact, the paradigm of amateur science. And I don't want to over-glorify you, and I don't want to over-glorify him, but I'm just pointing out that it really does have a place. So
I'll give some thought to that.
Now I brought up the amateur science, so I want to bring up something before I forget. You have, as far as I know, at least of 2009, the only photographs on Earth taken by you were taken of jet and sprite lightning.
Yes. Mm-hmm.
Is that right?
True.
Okay.
The only report I know is still true that my photograph, and it was of a giant jet over Mexico, south of Del Rio. It's about 350 miles from my camera, but I captured it with two cameras, not one. Both Snoopy and Rufus captured that thing.
You name your camera.
It was written up. There's no question about it. It was a giant jet. And there were a lot of sprites that I have a bag of sprites that I copied. And, you were talking about one time about the mention of stuff coming out of the radiation belt, being pulled out of the radiation belt as a possible source. That was one of the ideas one of the hypotheses. And there was some reason for that I won't bother to go into. But sprites are exactly that. They occur above really intense thunderstorms, electrical storms, and sometimes those electrical storms have enough electrical potential to be able to pull these ions out of their mirror points. And when they come down, they're red in color, and they're called sprites.
Yeah, but shouldn't you get a prize or something, some type of third-party recognition for having the only photographs of these two incredibly picturesque and weird kinds of lightning? Well,
I did get a little bit of attention from that. Actually, the giant jet was spotted in some of my stuff by a Frenchman. And he contacted me. He says, "Do you have any idea what that is?" And I said, "Well, I'm not sure, but it's interesting." He says, "That's a giant jet." And so he clued me in as to exactly what I have to do.
Okay, as long as we're dancing around this, what kind of mail do you get on this stuff? Do you get crackpot mail or like admiring mail? What's your feedback from these books that you've written and your discoveries?
The people, it's interesting that, there's skeptics really do their best to shoot holes in what I'm doing. People out there that they get their jollies, I guess, of pretending they're smarter than anybody else, and they say, this is blah, blah, this is just vehicles and blah, blah. And they can be a real pain. But other individuals, it's kind of interesting, from local people, the only people that have expressed outrage were people who realized, I think, that they were watching car lights. And based on what I was saying, they were watching car lights, and I don't think there's much doubt they were car lights on the highway. And anybody that sees these lights every night, for sure it's that highway. But some of them were outraged because they've been taking their friends out to show them these lights, and to have somebody come along and say, "You're just watching car lights," was upsetting. So they got a little disturbed about that.
Well, I want to jump in. They shouldn't be upset, and I think it's amazing and glorious to see lightning in West Texas and see any natural phenomena. But the truth is, they are not just car lights. If they were just car lights, everyone would say they're car lights, and they wouldn't pay attention. They're car lights that are refracted in a really cool way, and I think that's worthy. That shouldn't be. No one should be disappointed by seeing that. If all you're seeing are the car lights refracted by weird temperatures, that is, to me, a quasi-natural phenomena, and you should go home feeling rewarded by Mother Nature as well as by, General Motors.
Mm-hmm. Well, one of the phenomenons that does occur there are night mirages, and chapter 8, I believe it is, in my Strange Lights book, goes into that in some detail, and it's because the Mirages have chased cars on US 90. People think they're being chased, and the way the Mirage works, I go into the way it works, that makes them think they're being chased, and understandably, they really believe that there is a light chasing them, and they don't always like the explanation that I offer, but the explanation I give is just basic science, and it's real.
Yeah, I guess what I'm trying to say is I don't feel that people are approaching this the right way psychologically. I think if you see a mirage, that merits fascination. That merits a general sentiment of amazement and fascination. I don't feel that I'm not talking about you specifically, obviously, but anyone, if you see a mirage, or even if you have a hallucination, that to me is worthy of years of study. And if you see a headlight that looks like a floating UFO, that's pretty cool, even if you know that it emerges because of things you can explain. And I remember I once saw lightning in West Texas right around, not Mitchell Flat, but the McGuire Ranch, if you're familiar with that. Mm-hmm. It was like a video game between two clouds at two levels. It was never coming to the ground, just bouncing back and forth. And this went on for like minutes, and it was absolutely amazing. And I never once thought to myself, oh, it's just lightning. It's caused by pressure differentials and electrical. I thought this is an amazing thing produced by the Earth, explanation or not, and I don't require it to be a mystery to be absolutely blown away by it.
Well, I couldn't agree with you more. And while the mirage conditions are somewhat rare, they are rare. They're even more rare than the MLs. But I always really enjoyed mirage nights because it's just kind of like you're in a special world almost, because things are happening that you see cars driving through the sky and where they really aren't. And,
yeah, absolutely.
Probably the most interesting mirage I've seen is, where the municipal airport is located. You can see the light from the view park for the municipal airport. You can see that beacon when it's going around. But under mirage conditions, I would see that beacon spiral up and then spiral back down, and then spiral up and then spiral back down. It was just fascinating to see that. I tried to get on a camera, and I didn't succeed. Well,
I hope you keep trying. I agree with you absolutely. Now, I want to ask you this, straight up. You grew up in Presidio for about your first 7 or 8 years, I think. Do you recall what it was like to cross the border? Was it a big deal like it is now? Could you just walk across? Did you need passports and searches? Or what was that like?
I was there for the first 3 years of my life, and then between 10 and when I went off to college. So let's see. Well, actually not 11th grade. So between 10 years old and whatever, that would be about the 3rd or 4th grade and the 11th grade school, I was living in Presidio. And we went across to Ojinaga routinely for various reasons, Oasis Cafe or whatever. And I think things were probably much different then than they are now. The old bridge was it was really a one-lane job, and it was, as I recall, they improved it a lot to make it much better during that period of time. But initially, it was a wooden bridge with some metal plates that you tried to drive on. It was pretty narrow, and it was no big deal to go across. I don't know if it is now. I haven't been over there.
Oh my gosh! Yeah, of course, it's a big. You get searched and questioned and the whole 9 yards. Yeah. Did you speak any Spanish, or did your parents speak any Spanish? In the Presidio years?
parents, my father, stepfather, and my father both. My father was a customs agent working at Presidio when my folks were married. They divorced when I was 3 years old. But then he became a customs agent further up the line in Sabins and El Paso. My stepfather, I was lucky enough to have two fathers. My stepfather also spoke fluent Spanish. I did not. The hearing deficiency that I've told you about makes learning a new language really difficult, and so I can get by. I can find the restroom and a few things, but I have not acquired Spanish.
I remember when I told you about Marfa's big tourism industry and about its restaurants, you were shocked. You were amazed, even though you go there once in a while in the last 20 years. So tell me the style of town it was, the kind of town it was when you were going to high school there.
In which Marfa?
So you went to let's talk about Marfa. You went to high school in Marfa. What years were those?
My last year, my senior year, I was in.
No, but what calendar year was it?
Oh, let's see. That would have been 58.
Okay, so 58.
57, 58, I guess.
As I understand it, Marfa was a pretty robust town then, but it wasn't a tourist.
Yeah, it was. Population was larger. It was about 5,000 people, and it was a ranch town. The ranchers had power and money and airplanes at the airport, and it was a great city when I was growing up. I loved it. It was we had a theater, and it was a good people, friendly place, and all of the businesses on the main street there, those were all active businesses, every one of them. It was a thriving town in those days.
Do you remember the general excitement of rock and roll and anyone coming through town playing?
I do certainly remember the rock and roll era and how much fun it was. And the first time I saw that, I was in school in Presidio, and some of my Marfa friends went to Onaga and called me up and said, "Come over and join us." And so I went over and joined them in the Oasis Cafe, and they were doing rock, and I had never seen anything like that. I was taken by. I was really thrilled by that, and so I learned. Didn't take very long to learn to do rock and roll. I still do.
Yeah, I've talked to other people at the time who said it was such a big deal. Their parents told them not to listen to it. It was the loudest thing they saw, you know. And
I remember that the young women that I was interested in would sit around listening to Elvis Presley records, and they were so taken with him.
Yes. Well, I can tell you it continues. What about when John F. Kennedy was shot? Were you in Texas at the time?
Yes, I was. I was working for Ling Temco Vought, which is an aerospace company in Grand Prairie, which is a suburb of Dallas. And gosh, I won't forget that day. Nobody does that lived through it. The phone rang in the office, and some guy answered the phone, and he took the phone down, and he says, "Kennedy's been shot." And so everybody tried to get on the phones. They all went dead. Immediately, I walked across to the shop where the work crew that managed stuff that I was doing. I knew they had a radio, so I went over there, and they were listening to the radio, and I spent the rest of the afternoon there listening to the radio to try and find out what was going on. It was quite a shocking thing.
Yes, but the reason I asked is because I imagine it was more, it hit home, I guess it hit home for everyone, but for Texans, it must have been a very particular feel because, I don't need to go through it again, but it just seems like it was something very particular to Texas that this happened in their territory.
No, it was a big deal. It really was. And Kennedy came to Fort Worth first, and my current wife saw him speak there while he was in Fort Worth, and then he flew over to Dallas where he was killed. The thing that was it's a really small world, and sometimes things happen that are so unexpected. When Oswald was shot and killed, people were watching the TV, and my neighbor, who also worked at LTV, came rushing over and said, "Oswald's been shot, and you're not going to believe who shot him." And and I couldn't believe it. My friends couldn't believe it, because about 2 weeks before that happened, one of the guys in my office was getting married, and they had a bachelor party for him, and that bachelor party was in the strip joint in Dallas that Ruby ran.
Oh my goodness!
So we went over there, and it was a typical kind of bachelor party. But Ruby was really caught our eye, because there was something wrong with him. He was jumping all around the room, and I thought he was looking for trouble. And my roommate, at that time I had a roommate, and he was sitting in front of me, and he offered to help a young lady or something. I don't know. He stood up anyway, and here came Ruby, and he couldn't quite get to him, and so he kind of grabbed hold of me, and he says, "Pull him down, get him back here." And so I did, but I told my roommate, I said, "This guy's looking for trouble. We're going to have a fight here. Let's get out of here." So we got up and went down the stairs. It was upstairs, and exited. And sure enough, we'd no sooner than gotten out of there before he got into a fight and started throwing people down the staircase. And
wow.
What a shock, because it was, what are the odds, of something?
Yeah. Well, that's a great story. I mean, it attests to the craziness of Ruby and how volatile he was, but also very emotional. What you said you just nailed it. It's just a small world, like the connections we have with things. Well, let me finish with asking you the question that many people would have started with. But something that you mentioned in your book that I just thought was so meaningful in a way is that you really got hooked on hunting the Marfa Lights, and that's an apt title for your book, because you do kind of hunt them, particularly in the beginning. You actually try to catch the thing because you wanted to see the stuff that you loved when you were a kid. But unlike so many things from our childhood that we revisit and are disappointed by their scale and by how mundane they seem, came to show the wife in 2000 what you saw as a kid and you thought was really neat. And it was much cooler and much brighter and much more vivid. So tell us about your first look in the year 2000 at the Marfa Lights and how that got you into the game here.
Yes. Let's see, how much time do you have?
Yeah, let's say 10 minutes.
Okay. Well, all right, let's go ahead and run through that kind of quickly here. Let's see, the first part of my young life, between age 3 and age 7, we were living with my grandparents in Marfa, and my grandfather took me out to see the lights when I was maybe 4 or 5, something like that. He thought they were, he believed they were, I think I told you this before already, he thought they were automobile lights. I thought, growing up there, that there had to be an explanation, and I had an urge to go solve the mystery. I thought that I would take some angles and calculate the intersection, and I'd be able to then go take a look and see if there was a hole in the ground or if there was a highway or whatever, But I was busy with life and went off to university and then off to a working world and never got around, never found time to do that. But late in my career, my brother went back visiting. He had retired sooner than me, and he went visiting to Marfa, and he he wanted to carry out my idea, which to shoot some angles and see where the lights were, and he found a green light which turned red, and determined that it was a section light on the Presidio. At that time, you know, there's a track that runs from Ojinaga all the way to up to Alpine and on from there, and it goes right through Mitchell Flat. Mm-hmm. And at the time he was there, the train was still operating, and so they had section lights, you know, that turn trains approaching, and it turns from green to red. So he thought he'd found the answer, and he talked to our uncle, and the uncle said no, he'd looked into it, and there was a lot more to it than that. So I thought maybe I'd carry out my plan to look into it a little bit. At any rate, after I retired and moved back to Texas, I wanted my wife to get to see them, and we've been in Carlsbad visiting my stepfather. And on the way back, we stopped in Marfa deliberately so that we could go out and watch the lights, and we did that. And what I saw were the real thing. But I was so surprised by what we were seeing. It was just coincidence of timing, really, because what I was seeing, it just didn't seem like it could be real. And I thought maybe they were lights that were put out there by Marfa Chamber of Commerce or something. And so I went back the next night to see if I could track that down. Well, the next night, the lights were not just there; they were everywhere, and they were very dynamic, and they were doing all kinds of things. And I realized that I couldn't. This was not car lights. It was, you know, there was a lot more going on than I could explain away. And so then I went to the libraries and went to Sul Ross, and I thought smart people have looked at this. Somebody's got an answer. I read all of these books I could find on it, and I could shoot holes in all of the descriptions. I didn't believe any of them. And so I told my wife, I think I'm going to go back to Marfa, and maybe more than once, maybe even a couple of months, and I'm going to get to the bottom of this. Mm-hmm. It took longer than that to get to the bottom of it.
Yeah, well, let's say the jury is still out, but you have some amazing inroads. Just going through the ideas that people have had. What about? I was taken by the bioluminescent owls. What did you mention that really briefly? Because I'm sure you remember it better than I do. But someone has that theory, and you didn't completely reject it.
Oh, well, there's a guy in Australia that has that theory, and he was a nice guy, and he would write me, and he sent a book to me, and sent one to give to the library, which I did. And but you know, it's not real. I tried to be nice about it because he was sincere in what he was. He did believe that was maybe an explanation for the similar lights in Australia, Queensland.
Last question. You said you can't predict when you're going to see when the real Marfa lights are out there. Tell us a good way. I'm not thinking about like seeing the real lights or not, but just a way to enjoy the Marfa lights. So a good time of the year to go, a good time of the day to go, what to look for, what to bring. You know, set us up like we were going on some camping expedition. When is a good way to see the Marfa lights, to enjoy the Marfa lights?
the old rumor on that, what's the good way to see the Marfa Lights is with a cold beer and a pretty lady. But it's a little, I think your question probably deserves a little better answer than that. They can appear year-round, any time of the year. And I would pick warm weather because in the winter, the wind blows and it is cold as you just can't believe how cold it can be out there at night. So there's no reason to have to suffer that. Go in warm weather. Take something to sit on, preferably, certainly binoculars, with a pretty big lens, so that you can collect a lot of light, and know where to look. Look at my book or something so that you know how to avoid looking at where the car lights are on the highway. You stay away from those. Look back to the southeast, and then dress warmly, because even in warmer weather, the weather at night there is usually quite a bit cooler than it is during the daytime. It's, as you know, it's high terrain there. It's almost mile high. It's 4,900 feet or something where the view park is. And then just enjoy it. The skies are beautiful. There's very little light pollution, whether you get to see anything or not. You got a gorgeous sky to watch, and it's interesting making the attempt, because you see ranch trucks and you see various things, and if you're lucky, you get to see what you went for. But even if you aren't, it's a fun thing to do.
Okay, and this is the final question. How will you know for sure if you're looking at plasma?
Well, if you were looking just at plasma, the specter would show it, but these lights, which have plasma in the center, don't show it, because what you're seeing is really the fire that's a gas fire that surrounds the plasma, and so the specter doesn't reveal it. One of the tip-offs that you've got the real thing is that they do turn on and off. That's one of their characteristics. And that's interesting, because they're able to reignite. And I go into that in my book, how I think that happens, why it is possible for them to reignite.
James, let's end it there. I'm going to go to dinner. This has been a great call. Thank you very much for your help. If you come to Marfa sometime, look me up. Just go to the radio station and ask for me, and I would love to say hi in person.
Well, yeah, I'd love to do that.